today we are going to talk about the Cartesian coordinate system. This is just the state standard that it's going to follow, and this is actually what we really have to pay attention to. The lesson objectives is kind of just the summary of what you're going to learn today. And then if you can take out your notebooks and at the top of the page write down the essential questions. The first one is, what is the Cartesian coordinate system? And the second is, how can we properly use this system and apply it to our everyday life? And then I would give the students a few minutes to actually write that down before I go on. Also, I have a handout that has the terms to know, and at this point I would actually call on students to read out each term, but since I don't have any students, I will just read out the terms. The first one is coordinate plane. A plane with a point selected as an origin, some length selected as a unit of distance, and two perpendicular lines that intersect at the origin, with positive and negative directions selected on each line. Coordinates, a unique ordered pair of numbers that identifies a point on the coordinate plane. The first number in the ordered pair identifies the position with regard to the x-axis, while the second number identifies the position on the y-axis. In a graph, a visual representation of data that displays the relationship among variables, usually cast along x and y-axis. And negative numbers, numbers less than 0. In graphing numbers to the left of 0, negative numbers are represented by placing a minus sign, right, just like that, in front of the number. Now, you don't have to know these right away because they're kind of confusing if you don't know the coordinate system, but you will need to know these for your exam in a couple of weeks. So just a little history of the Cartesian coordinate system. In 1637, Descartes and Pierre de Fermat created the Cartesian coordinate system, and Pierre actually did not fully create the one that we're going to learn today. He created a 3D version of it, and he actually never published his work, so he gets a little bit of credit, but mostly Descartes gets most of the credit. And the Cartesian coordinate system was actually the link to help us form the math form called calculus. And then there's also some different coordinate systems. We're not going to learn about these today. We'll learn about them in the future, but one is a polar coordinates and the other is spherical and cylindrical coordinates. All right, class, so now we're going to have a little pop quiz just to make sure you are paying attention. And I'll have volunteers, and if no one actually raises their hand, then I'll just start calling on people. And at this point, I would have the students come up, and I would have them write down the answer to each one. On the first one, I'd have a child come up and write, I'd have the child use the pen so they can kind of get used to writing on the board. And the first one would write down 1637. And then question 2, name one of the two people who helped develop the coordinate system. And hopefully they would name Descartes because he was the one who was most important in forming the coordinate system. And what form of math did the Cartesian coordinate system help to develop? And that would be calculus. And as I said before, if the kids didn't actually come up and volunteer, then I would start calling on them. And this is just kind of like a checkpoint to make sure that they know that there's going to be quizzes, pop quizzes, and they need to start paying attention to information in the history. All right, so now we're actually going to get into the Cartesian coordinate system. Basically what this is just graphing points and the location of where that point is and how we can identify where someone is or something. And so to apply this to everyday life, we're going to have a little activity. And at this point, I would call on a student and I would ask them to identify where another student is in the class by following the chairs. So one of the students would try to identify where Johnny is sitting, and that he would say, Johnny is sitting 4 chairs down and 2 chairs back. And that is just kind of like to apply it to everyday life. So when we're drawing a graph, we have a vertical line that will go straight down. And this vertical line, they have called it the y-axis. And then it usually will split right down the middle of the graph. And then the second line is the horizontal line that goes straight through, and it's known as the x-axis. Intersect, it's going to be starting at 0. And from 0 on the horizontal line, you're going to count, and in every line will be 1, 2, 3, 4, 5, 6, and so on. And then from 0, just like in our terms to know, how we were talking about the negative numbers, you're going to start counting back negatively. So it'll be 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and so on that way. And that would be our x-axis. And in the same sense, on our y-axis, we're going to go from 1, 2, 3, 4, 5, and this would be just counting up and then follow that pattern. In the same way, negatively, when you go down, negative 1, negative 2, negative 3, negative 4, negative 5, and so on. And you kind of understand how we lay out the Cartesian coordinate graph by following that. Here's one that's a little bit neater than me drawing it out on the board, and I already created this. And at this point, I would ask the child to again identify where Johnny was sitting. And I actually just forgot the points that I said. But say he said the student was 6 chairs down, we would count over with the student. We'd say 1 chair, 2 chair, 3 chair, 4 chair, 5 chair, 6 chair. And then if he said the student was 2 chairs back, we would then count negatively back. It would be 1 chair, 2 chair. So in the classroom, the student would be located right there. And that would be kind of like a way to apply it to everyday life. All right, so now that we kind of understand how to use the graph, there's also a few more terms that we're going to have to become familiar with when we're describing where the point is. And this is the first quadrant, second, third, and fourth. It's also sometimes identified by the Roman numeral. And so that would be 1, 2, 3, and then 4. And this is just another way for if you want to say where your point is located, instead of saying the top left box, the top right box, instead you would just say the second quadrant. And an easy way to kind of remember how to label them is you go counterclockwise, and that creates a C for the Cartesian coordinate system. So now we're going to look. Okay, so now we're going to watch a video, and it's kind of just going to sum up what we just talked about, but more with visuals.
Okay, this is a quick introduction to the Cartesian coordinate system developed by Frenchman, philosopher who lived several hundred years ago. The Cartesian coordinate system is a system whereby we can locate points on a plane. That is, we can figure out where dots or locations are on a flat surface, and we can do many other things with it as well. So we'll take a look. You may already be somewhat familiar with the Cartesian coordinate system by the connect the dots game that you may already know, and that is, if you connect the dots, you would see that we have something that looks like a dolphin. Here, if you connect the dots, you can see that you would have a circle. You may be familiar with graph paper. It has lines all over it so that it will help you be able to draw things and keep it straight. It too is based on the Cartesian coordinate system. And you already know about length, inches, feet, miles, things like that. The Cartesian coordinate system is just length in 2 different directions. And later you will learn about length in 3 different directions. What we call the x direction, the horizontal direction, you've seen represented here at the bottom by a line, and we can rotate another direction 90 degrees. So here we have the x direction, and here we have the y direction. It's 90 degrees and to the first one, and it looks like this. So one direction we call y, and this direction we would call x, and x comes first, then you have y comes second, and it's just like in the alphabet. X is first, then there's y, and you have it what's called an ordered pair. The ordered pair here, x, y. X is some number, y is some number. It gives you the address, the location. Let's talk about and take a look at how that works. Here we have the x direction with 1, 2, 3, and we have the y direction with the positive 1, 2, 3. And so if we were to have the ordered pair 1, 1, it gives us the address x is 1, y is 1. Well, here we have x is 1, y is 1, and that gives us the location of 1, 1. And there's the ordered pair. Now, what if we were to have 3, 2? Well, x is 3, y is 2. That gives us the location of the dot, 3, 2, and there's the ordered pair. So far it's worked out that everything's been positive, but what happens when both of the numbers or one of the numbers are negative? Well, we'll take a look at that. Here we have 9, negative 2, or negative 7, 3, or negative 4, and 2. We'll take a look at the expanded kind of Cartesian coordinate system with the x and y both being positive and negative. So we have the ordered pair 9, negative 2. So we have x is 9, y is negative 2. That gives us the location of the red dot, which is the ordered pair 9, negative 2. Negative 7, 3. We have negative 7. We have positive 3. Y is positive 3. Gives us the location of the dot and the ordered pair. If we have negative 4, negative 2, that gives us negative 4, negative 2, the location of the dot, and there we have the ordered pair, negative 4, negative 2. But what happens when we want to talk about different areas of the Cartesian coordinate system? Well, this is quadrant 1, that is quadrant 2, quadrant 3, quadrant 4. We don't then go to quadrant 5, it just becomes quadrant 1 again, and sometimes we represent it with just the numbers, and sometimes we represent it with the Roman numerals. The rotation of the quadrants are starting with the first, second, third, and fourth. It's just like you were drawing a capital letter C for Cartesian coordinate system. So you would start in the first, go to the second, go to the third, and wind up at the fourth. In an ordered pair, which comes first? The x comes first, just like in the alphabet.
Okay, so we're not going to go over all the review because we're actually going to have a quiz at the end, and that will review for us. But that was just a good video to kind of like put the stuff that I just talked about into a visual sense. Alright, so as the video talked about, when we have the numbers, it's going to be x first and then y, just like in the alphabet when you say your ABCs. So it's very easy to understand, and so I have created, it's kind of like a connect the dots with the points, and so at this point I would then call on different students, and I would have all the different students come up and graph these points. And so Taylor, if you want to come graph 2, that'd be great. Is the first 2? Yes. Okay. 0, 8, and 7, 4. Perfect, thank you. Alright, so I kind of already graphed them in so we did not have to watch me graph all the points. But then I would have the students realize that they've now put all the points on the board, and so then we would just connect the dots as a fun way to show what they have just graphed. So yeah, it may be kind of funny looking, but it's supposed to be a star. And that would just be another visual way to have the kids come up on the board and be interactive with technology. All right, so now at this point, I want everyone to take out a piece of paper, and you can work in pairs with this as a class quiz. And I need a piece of paper, and then also from your graphing notebooks, I need a graphing page, and you can draw the y and x axis and then finish this quiz, and then you can turn it in and you are free to go.